Students, in the previous class, we have started inversion of single threaded crankshaft mechanism. In that, we have seen the working principle of single threaded crankshaft mechanism, later inversions of single threaded crankshaft mechanism. Then we have seen about Whitworth quick return motion mechanism. After that, we have studied about rotary internal combustion engine. Today, we are going to see about crank and slatted lever quick return motion mechanism. As I told already, quick return mechanism means the forward motion or cutting stroke will be slower than the return motion, because in the return motion, in most of the machinery items, the tool will not remove any material. In the forward stroke only, tools will cut the material or remove the material. Okay, so the forward stroke should be slower, so the cutting process will be very smooth and it can remove more materials and it will not affect the cutting tool. Also, it will not damage the surface of the object. So the forward stroke should be slower than the return stroke, or cutting stroke should be slower than the return stroke. Now let us see the parts in the crank and slat quick return mechanism. First of all, AC. AC is a AC is a fixed link. AC is the fixed link. Then CB. CB is a crank. CB is a crank. Then B is a slider. CB is a crank, then this is slider. This element is slider. As usual, in the previous case also we have seen slider was inserted inside the slotted bar. Here also AP, AP, this link is a slotted bar. This element is a slotted bar. This is slotted bar. So the slider was inserted inside the slotted bar. Okay. Now this AP1 and AP2, AP1 and AP2 are the extreme position of the slotted bar. Okay, AP is a slotted bar, AP1 and AP2 are the extreme position of the slotted bar. When the crank rotates, the crank is rotating based on the fixed point C. Okay, when the crank rotates, the slider will try to rotate. At the same time, slider will move up and down inside the slotted bar. So it will make the lever, it will make the slotted bar to oscillate. It will make the slotted bar to oscillate like this. Okay, so AP1 and AP2 are the extreme position of the slotted bar. Okay, at extreme position, the crank will make 90 degree to the slotted bar. This is the crank position. Okay, this is a CB is the crank, and CB2 and CB1 are extreme crank position. Okay, so this is the crank position. So this crank will make 90 degree when the slotted bar is at extreme position. Similarly here also, when the slotted bar is at extreme position, crank will make 90 degree. Okay. So as usual here also, cutting angle and angle for return stroke. Forward stroke angle alpha. When the crank travels from this point to this point. When the crank travels from this point to this point, okay, this point to this point, cutting tool move in the forward direction. That is, ram will move in the forward direction. At that time it will remove the material. When the crank travels from this point to this point, okay, greater angle beta is greater than alpha, okay, or this angle beta. When the crank travels from this place to this place, ram returns to its original position. So during cutting stroke, crank will travel the angle alpha. During return stroke, crank will travel the angle beta. Okay. So when the slotted bar when the slotted bar oscillates, when the slotted bar oscillates, ram will move front and back. Okay. Cutting tool is fixed on ram. So when the ram move in the forward direction, cutting tool will remove the material. When the ram move in the reverse direction, cutting tool will move freely without cutting any material. Draw this diagram neatly while answering this question. You have to draw this diagram neatly with the pencil. You have to mention this angle alpha, beta. In the previous case, beta is the cutting stroke angle, but in this case, beta is the return stroke angle. Okay, easily you can remember alpha, beta. In the previous case, beta is the cutting stroke angle, but here in this case, crank and slotted lever quick return mechanism, beta is the return stroke angle. I'll show you some animation so you can easily understand it. So beta by alpha, time for forward stroke to time for return stroke, the ratio of forward and reverse stroke. So that could be understood by the angle beta by alpha. So this derivation, we got this equation from this derivation. Okay, we got this beta by alpha, this formula. This is a kind of formula. We have a problem based on this. I will show you the problem. So this formula is derived from this derivation. Okay, where P1, P2, R1, R2. Look at this diagram. This is P1, P2. Okay, this is R1, R2. So from the diagram itself we can understand length of P1, P2 is equal to length of R1, R2. That's what they are given here. That's what they are given here. Now they have taken the triangle PAQ. Okay, instead of P1, P2, we can write either QP1, 2QP1 or 2QP2. We have to take any one side, either this side AP2Q, this triangle, or AQP1, this triangle. We have to select either one triangle to solve this derivation. Here in this case, they have selected AP1 triangle, this triangle. They have selected this triangle. Now we know that 2QP1, P1, P2 is also equal to Q is middle point. So P1, P2 is equal to 2P1Q. Okay, 2 times of this length. Total P1, P2 length is equal to 2 times of P1Q length, P1Q length. Okay. Now P1 PQ, instead of writing P1 PQ, because we have to bring the angle inside. We have to bring the angle inside. Okay, we have to bring the angle inside. So instead of writing P1 PQ, we can write A1P. A1P is the length of the slotted bar. Slotted bar. Okay. A1B and angle. This angle. Okay. This is how we got this formula. Okay. We know that adjacent side by hypotenuse. Adjacent side by hypotenuse. Okay. What is the formula for that? Adjacent side by hypotenuse, cos theta. Opposite side by hypotenuse means sin theta. So we have taken this angle. We have taken this angle. This angle. This angle value is 90 minus alpha by 2. Okay, because this is the total angle is alpha. Total angle is alpha. Now this half of the place. Half of the place is alpha by 2. Okay, what total angle? Total angle is alpha. Now the middle up to fixed length. Up to fixed length alpha by 2. Alpha by 2. Okay, so this angle is alpha by 2. This angle is 90 degree. This angle is 90 degree. So what should be the value of this angle? In a triangle ACB1, what could be the total degree? The total degree is 180. Total angle is 180 degree. So this side is 90 degree. So this side is alpha by 2. What is the angle of this side? What is the angle of this side? That we have to find. Okay, let us consider that as x. When this 90 degree come to this side, what will happen? 180 minus 90, 90 will be answer. Okay. This alpha by 2, when it comes this side, it will become minus alpha by 2. Equal to x. Do you understand how you got this value? This is how this value came. This is how this value came. 90 degree minus alpha by 2. Okay. Sure, right. So now we got this value 90 degree minus alpha by 2. Now, so take this angle. Take this angle. Sine 90, sine minus, if you take sine 90 minus alpha by 2, what would be the answer? Sine 90 minus alpha by 2 will be equal to opposite side. What is the opposite side? Opposite side for this angle is P1Q. P1Q. Hypotenuse. Hypotenuse value is AP1. That is the hypotenuse value. Okay, that's what they have mentioned here. That's what they have mentioned here. Okay, what I need is P1Q. So P1Q will be equal to A AP1 minus sine 90 minus alpha by 2. That's what they have given here. Instead of sine minus 90 by 90 alpha by 2, they have given P1AQ, that angle. Okay, both are same only. In the next step, they have introduced the value. Okay. So sine 90 minus sine alpha by 2. Sorry, sine 90 minus alpha by 2 means that will be equal to cos alpha by 2. Okay. Sine 90 minus theta equal to cos theta. Sine 90 minus theta equal to cos theta. That's why sine 90 minus alpha by 2 means that is cos alpha by 2. Okay. And cos alpha by 2 is equal to CB1 by AC. This is how we get this equation. So this is an animation for crank and slatter lever quick return mechanism. Already we have seen the diagram. I have explained the diagram. Here they are given the animation. This is a shaper. In shaper they are using this quick return mechanism. I hope you have understood this concept. Quick return mechanism. I hope you have understood this crank and slatter quick return mechanism. Try to draw the diagram once and read the concept and try to write it once. We will see the next mechanism in the next class.